Neil, thank you very much for your time and talking to us. Maybe before we even get into the kind of the crux of this matter, what is graphene and why is it this wonder material?
So graphene has been around for a long time. We theorized about it since the early part of the last century. But it wasn't until 2005 that we were able to actually isolate it and understand what this new material is. So if you imagine that graphite, which is a kind of a collective of graphene, is like a deck of cards, what we do is we take individual cards out of that pack. So each one is just an atom thick. The thing is when we first thought about graphene, we thought about it as having the same properties as the underlying material, graphite. But actually what we learned in 2005 is it has the most incredible properties of its own. So massive electrical conductivity, very good thermal conductivity. It actually improves the strength of most of the things that we use on a day-to-day basis. And some people wonder why it's taken from 2005 to now to start to see some of these benefits. But I caught a little bit of what you were talking about before with COVID-19 in the kind of preamble before this. And it's those kind of events that graphene can really make a big difference. So if we want to talk about water filtration and giving clean water to the rest of the world, if we want to talk about reducing plastic pollution, the move towards electric vehicles, then graphene is the enabler that makes that happen.
You're obviously a leader in this space. And when you look at the technology and the development, just talk to me about which rabbit hole did you have to go down in terms of the research and the application of this material? Because obviously you're ahead of everybody. So how do you see the application of this material?
So we're very fortunate that our particular journey revolved around the University of Manchester, where it was first isolated by the two Russian professors there. And since about 2011, there's been a lot of work done on actually taking this material, not only creating it in a variety of different ways, but then actually being able to use it in the applications that we want to be able to use it in, everything from construction to energy. What we've done more recently, probably in the last 2 or 3 years, is get that independent data, learn how this new science is developing. And it's very much like when the first light bulb was switched on or when the first silicon chip was generated. It's that kind of excitement around this new technology and how we're going to use it. So it came as a bit of a surprise to me, but for instance, we talk about the production of CO2 across the world. The reality is that the production of concrete is probably one of the biggest, if not the biggest, producer of CO2 in our world now. Massive developments going on all around the world. The use of concrete hasn't really changed for a number of years, but graphene can add 30, 40, 50% extra compressive strength to that material, which means that you don't use so much and you can change the process by which we create it. So the thing for me is it's this kind of wonder moment where we take this technology and we use it in all of these different industries right across a whole range of different fields. And that's the kind of the real excitement.
Neil, talk to me about your company, Versarien. Um, I think you're just listening to you. You you kind of remind me of a Tony Stark, where you saw the value of something. At what point did you know that you could commercialize it, and how did the company then develop?
So we first bought our spin out from the University of Manchester in 2014, and then we worked with the University of Cambridge over here in the UK and bought their spin out in 2017. And when you see a process in a laboratory, and in the very early days, we were making 0.5 gram a week, with a couple of real talented PhDs in a fume cupboard. And you see that and you think, how can I take that to something that we can produce tons and tons and tons? And my background is as an engineer, so I'm the person who takes those clever ideas from the clever people and turns them into things that we can actually use. The rest of my team have been with me for up to 30 years, and we've gone through those journeys together many, many times. So what we're doing now is we're working with the very clever academics at those institutions. We're listening and understanding what they're doing. And then we're the kind of missing jigsaw piece that enables that to be used in everything from textiles, where we want to improve the efficiency of an athlete, through to protecting people in terms of bulletproof vests and lots of other technology. So the excitement for me is really about actually delivering these products, making a simple device like a container for orange juice, making that much better at its job, much safer for everyone that uses it. Being able to actually create a lot of these kind of light bulb moments where the technology is used to perform a really good event. More recently, we've been working on face masks for the COVID-19 epidemic. A lot of people have had their lives radically changed by COVID. It doesn't matter whether they've lost their jobs because their businesses haven't been able to survive, or they're actually kind of in danger from this disease that has kind of ravished the world. And what we've been able to do is work with the technology and work with our suppliers to be able to come up with an antiviral, antibacterial face mask, which works much better than anything else that's out there in terms of its testing. And that's a really key moment for me, because that's about bringing this technology alive. I don't get too excited about the stuff that's going on in the laboratories. That's for the very clever academics. What I get really excited about is when I see the products on the street and I see people's lives being changed by this technology.
Yeah, it does sound exciting. Now, you've got an NDA with CSIR. I know there's a ton of stuff you can't talk about, but what does this collaboration look like?
So we believe that there should be a much more kind of collaborative approach to the way that companies operate. And we don't really mind working with our competition. We don't really mind working with other companies. And the reason for that is because we think that gives us a much stronger proposition if we were to kind of work together. So we might not be the experts in the manufacture of masks, for instance. So we find someone that is. And with CSIR, then what we're doing is we're working with them in order to be able to bring all of their strengths and all of our strengths together to be able to achieve the best result on the projects that we're working for. We have collaborations with lots of organizations, whether they're learning organizations, and academic research, like the University of Manchester and the University of Cambridge, but also with commercial organizations. So what is really, really important for a lot of these companies? So if you're a packaging company, it's about improving your performance, making your goods last longer, reducing the amount of plastic that we're using, stopping that plastic getting into the oceans. If you're a construction company, as we spoke about, it's about reducing your CO2 levels and producing the very best components that you can. It goes across almost all industries, whether that be rail, the aircraft industry, and the automotive industry. CV19 and big events like these are actually really good things for technology in terms of really making us think about how we can actually change the future. And that's what this relationship's all about. It's about having the foresight and working with the right organizations to be able to create a much better future for everybody.
Neil, what do you think are the key requirements, at least in terms of success, when you look at technology development? But more from a policy point of view, how do we frame policy to make sure that we do have more success when it comes to technology development?
Creating new technologies is a very difficult thing. It takes it out of you. It's not an easy journey. Anybody who's been involved in technology transfer or in technology development knows that you have to fail an awful lot of times. I think it was Edison that said that he failed 100 times or 100,000 times before he got his success. And so you need relationships which are going to overcome those challenges that you run into. We've talked about it several times during this interview. This has been a really challenging times for companies. If you haven't got those very, very strong bonds, if you don't have a shared vision for what the future should look like, then they tend to fall apart. And we see that all the time if people aren't really, really committed. And that starts at a government level as well. We're very lucky to be supported very well by the UK government, because they've identified that this is a technology that could really have a big impact on society in the future. And that policy has to be driven through. It's much easier to take an easier path. And I think with technology development and technology transfer and development of these technologies, you need those really strong bonds. So that's what we're hoping with this relationship.
As someone who sits at the cold face and deals with, let's use this example, graphene as a wonder material, for somebody who doesn't understand, what would your world look like if there was a policy shift and governments accepted graphene as a key component in driving technology development? But now that we're in COVID, how do you think a wonder material like graphene could make the world better?
So we've talked about these really enabling technologies. Graphene is just the first of these materials. This is a brand new science. It's a new way of looking at materials. So if you think of the world without cotton, or you think of the world without polyester or nylon, then you realize how kind of stark the world would look. And that's how I kind of look at the world now. I look at the world without these graphene reinforced and enhanced materials as being kind of where we were 200 years ago. Because we have the ability to be able to make these changes, what we need to do is we need to force change. And as you said, that comes through regulation. It comes through having this shared goal. If we talk about energy, for instance, we've kind of squandered energy over the years. It's been there, so we've just used it. And now we're getting to the point where actually, we could use renewable energy, we could use solar, we could use wind. The thing that lets us down is that we need the infrastructure, we need the battery technology. Now, if the governments actually turn around and enforce that through regulation, then we see a big change. I'm a great lover of what Tesla's done to the automotive industry. I've worked in the automotive industry most of my life. And it takes someone like Elon Musk to actually get people to look at how the future could be. And, what we're seeing in the UK now is people are really considering electric vehicles. In the UK, I think it's something like 1 in 20 children will be affected by pollution. And most of that pollution comes from cars. Now, we've kind of been used to having those cars available. And so we've kind of never really questioned that there might be a different way forward. But what we're seeing now is because there's been a taxation reform and EV vehicles are kind of better in terms of taxation, there's a mass switch going on. And that's now putting a kind of challenge onto the technology to catch up. Now, if we can do that with electric vehicles, imagine what else we can do with. If we can do that with plastic pollution, if we can do that with energy, construction, aerospace. I mean, 20 years ago, if you were talking about electric planes, people would have locked you up because we always made planes the same way we did, from the Great War. And now we're actually got a situation where people are having to really look at what the future looks like. And so they're more encompassing, more embracing of that change to new technologies. We don't really, as a society, change that much. We kind of hold back on change. And sometimes those people that are bringing change are kind of thought to be a little bit crazy, to be honest. But actually, over a period of time, that change becomes the kind of norm. So that's what I'm looking forward to.
Neil, are you crazy?
Just a little bit, but I put it down to my kids. So I remember when we started this business in 2013, we started in my garage. In 2011, we started in my garage. And in 2013, we moved into our very first little unit. And I brought all these dignitaries in to have a look at this little unit and tell them how great the future was going to be. And 9 out of 10 of them thought that I was crazy. And now we have these big factories in the UK and people, they come along and they have a look at these factories and they can actually see it. And for most people, they don't have that vision of how the future can be. And it's a bit like looking in black and white and in color. And I can see the future in color. I can see how we can bring these technologies to life and actually change the ways that we do things, a really good benefit for all societies, not just, in local areas.
We know that everybody's talking about 4IR and the role that 4IR can play in society. Just talk to me about this kind of advancements, especially in the context of 4IR, is when you look at materials. I know that At a policy level, we're talking about it. At a society level, we're talking about it. But here you've got a wonder material like graphene in the context of 4IR. Could it advance that conversation? Does it really make a case for us getting deeper and rolling up our sleeves and really unpacking the value of 4IR?
I think it does. I think, as I've said to you before, this is a real technology change. It can alter, just about everything that we're involved in. So for me, uh, you know, this is a real enabling technology that lets us kind of embrace all of the challenges that we're seeing in society and really pushing those limits. As I said to you before, it doesn't really matter which area of society that you're looking at. These new materials, and as I said to you, graphene is just the first kind of carbon-based material. But when you start looking at the benefits of some of the other materials, we're seeing big changes that we can make using maybe 2,000 or 3,000 different types of materials. So that for me, it's really just, we've just kind of opened the door slightly to some of the challenges that we can actually overcome.
Final question from me. With the way COVID has changed the way we communicate, how we engage with each other, with the kind of red tape that we've been able to deal with even more swiftly. A year ago, it would have taken you 6, 7, 8, 9 months to facilitate a conversation. Now with this, now with COVID being in the room, have you seen an urgency from leaders like yourself, players in your space, government, to fast track some of these amazing initiatives?
I think that is just starting, to be honest, and we probably need to be more proactive in getting those doors pushed open. I think, as I said to you before, we're kind of risk averse as a society, and we tend not to embrace change very well across the masses. And so I think it has started, but it is nowhere near reached the momentum that it needs to. These challenges that we've kind of brushed to one side, communication is a classic example. Medical prevention of diseases is another one. These are big challenges that can be solved with these materials, and we just haven't got the momentum yet to be able to actually embrace some of this stuff. If you take, I love traveling. I'm a diver. I love seeing the oceans. I love photographing, a completely different environment. So I love to travel. We will not be able to travel if we do not change. The aircraft industries will not be able to survive the way that they've been operating for the last 30 or 40 years. They need to accept that they need to change. It's the same with the automotive industry, and it's the same with the communications industry. We have some really, really good opportunities at the moment to really challenge what we're doing. There should be no reason why people should not join people on this journey that we're on around challenging what we do. COVID-19 has been absolutely disastrous in the UK. It's cost people's lives. It's been an extremely traumatic experience. My parents are in their 70s. They've been locked in their house for 7 or 8 months because they're too scared to come out. But actually, it's also had some benefits in the way that it has enabled these conversations, as you talked about, where we're challenging regulation. We're forcing the decision makers to contemplate a different future, not the future that we had 10 years ago. Currency is another area in which there could be big changes in the financial services. That's all built on data. It's all built on getting the next technologies, which will come from these materials. But we need to invest. And I'm very fortunate that the UK has invested very heavily into the University of Manchester and the University of Cambridge. And we've been joined by European colleagues. But there's more work to be done. There's more of these relationships to be built. And this relationship that we're talking about now with CSIR it's all about actually being joined up as a global society and not seeing those barriers, not seeing the barriers of geography, being able to communicate like we are now across a great distance, would just not have been possible a few years ago. And we would have got on a plane and I would have come and seen you and I would have talked to you for 15 minutes or 20 minutes. But now we're able to actually challenge that and to have these conversations. And I've had some great conversations with CSIR about, what the future could really look like. And so for me, it's really about everybody challenging what we do.
Neil, thank you very much for your time.